Today we are going to see about tree data structures, which is the most important topic which you have to go through while studying data structures. So in tree data structure, first we'll be seeing what is a tree ADT, how it aligns with the real world environment, then further traversals, then we'll be seeing about different trees like binary tree ADT, expression tree, binary search tree, AVL tree, and further B and B plus tree. So let's move on to the video. Before going into the video of trees, we'll see about a simple flashback of our data structure which we saw previously. So we saw two data structures, which is linear and non-linear. In linear data structure, we saw about array, stack, queue, linked list, and in non-linear data structure we are going to see about trees and graph. So what is the difference between these two, linear data structure and non-linear data structure is, so in linear data structure you will be having only one predecessor and one successor. So if you are moving forward, you will be having one successor, so your decision is easy. So if you are moving backward, that is backtracking, also you will have only one node which is a predecessor. So in that direction also your processing is easy. So this is all about linear data structure. But in non-linear data structure, so your trees, that is a node, will have more nodes further. Okay, so a node will have many child nodes, which make your decision hard. So you have to make a clear decision whether which node you have to traverse next. So this is the difference between linear and non-linear data structure. In linear data structure, we saw about array. So in array, the memory allocation is fixed, which means your memory is allocated during the compile time itself. So the next we saw about linked list, where you will be having a head node and the further nodes is connected using a link. Okay, so this is about linked list. So after that we saw about stack. So stack operates on LIFO principle, which means last in first out. The elements which gets in first will get out last. So the insertion operation is called push and the deletion operation is called pop in stack. So the next data structure we saw is queue. So in stack data structure will be operating only one end, that is at the top, but in queue data structure will be operating at both the ends, that is front end and rear end, where your insertion will be done only in the rear end and the deletion operation will be done only at the front end. So these are the linear data structure where you have only one predecessor, that is for moving backward you will be having one predecessor and moving forward you will be having one successor. So your decision will become easy. So now we are going to concentrate on linear data structure, where you have several nodes when you move forward and several nodes when you move backward. So you have to make your decision clear and several constraints you have to follow to make your decision clear. So with this we can move towards the tree concept in data structure. So what is a tree? So in real time example, we all have seen tree. What are all the components your tree will have? Your tree will have a root and your tree will have branches and leaves. So same way in computer science, we have a root node, and a root node is followed by the further nodes, which can be a child node, that is which can be a child node or parent node. So these are all the parent nodes which have child nodes. The parent nodes are the node which have child nodes. So these two are called parents now, and this is the child nodes of this parent. So the nodes which doesn't have any child nodes are called leaf nodes. So each and every node is connected with the edges in computer science. So each and every node is connected with the help of this edge. So same way how we see a tree in our real-time environment, we are going to follow the same components in data structure tree also. So why trees matter in our digital world? So where are the trees are applied in real world. So for example, let me consider our family tree. So tracing ancestry, which means my grandparents, their grandparents, so these histories can be tracked with the help of this family tree. So where else it is used? In file systems. So organizing folders and files in your computer, obviously it follows the tree data structure. So then next one is tournament brackets. So which means if you're going for a tournament, the teams will be fixed using this data structure. Where we can apply this data structure is several teams will be participating in that tournament. So each and every team has to compete with the another team until a winner is finalized. So this fixes is mapped using this data structure. So what is the key challenge in this data structure is how do we traverse, which means how do we visit all these nodes, and how do we store and how do we search for a hierarchical data in this tree data structure is a key challenge.